Good morning, children. Now today we are going to discuss about the structure of nephron. Here already we have studied about the urinary system in humans, and in that urinary system the main we are having only two kidneys. The two kidneys are filtering the blood because nephrons are present on the kidney. On each kidney 1 million, more than 1 million filtering units are present. Those filtering units are called as the nephrons. Nephron is the structural functional unit of kidney. Nephron is the structural functional unit of kidney because it filters the blood and removes the nitrogenous waste materials from the blood. Now coming to the parts of the nephron. Mainly nephron has two parts. One is the renal capsule. One is what? Renal capsule, and other is the tubular part. This is the capsule. Renal capsule also called as the Bowman's capsule, and this is the tubular part. Now in this Bowman's capsule there are small coiled capillaries. So here what are these? Glomerulus means what? Small coiled capillaries. Small coiled capillaries are present. A group number small coiled capillaries in many number are present. They are surrounded by squamous epithelium. The capillaries are surrounded means in and out squamous epithelium tissue will be present because these are all having the permeability. Permeability means they will allow the certain substances to go in, exit and entry. Now here this is the Bowman's capsule or renal capsule, which has the small coiled capillaries which are surrounded by squamous epithelium called as glomerulus. These are only the filtering unit. Now after this Bowman's capsule, this is the tubular part. Now you see the convolutions here, convolutions. So PCT, proximal convoluted tubule. The first convoluted part is called as the PCT, proximal convoluted tubule. Next is the U-shaped one. Here the hairpin bending and the U-shaped tube you are observing. No, this is called as the loop of Henle or Henle's tube. Then again the convolutions you are observing. This convoluted tubule is called distal convoluted tubule, and this distal convoluted tubule joins to a duct called collecting duct. Again, so the capsule is called renal capsule or Bowman's capsule. It has large number of coiled capillaries which are surrounded by squamous epithelial tissue. And now the tubular part is having first the convolutions you are observing. No, this is the proximal convoluted tubule, and the U-shaped tube is called loop of Henle. Again the convoluted part is called distal convoluted tubule, and it is connected to collecting duct, where this Bowman's capsule receiving the blood from the renal artery. See, the artery which is bringing blood to the kidneys, or this Bowman's capsule is renal artery. We can again call it as the efferent, AFFERENT, efferent arteriole, which is coming in. Efferent arteriole, renal artery, which brings the blood with nitrogenous waste materials. So we know that the nitrogenous waste materials are urea, uric acid, creatinine, and there are many waste materials which are accumulated in the blood. They should be filtered time to time, otherwise these are providing the toxic substances and infecting the whole body. So we need to filter the nitrogenous waste materials from the blood. The renal artery brings the blood with the nitrogenous waste materials to Bowman's capsule, and in this capsule the glomerulus are present. No, they are filtering the blood. They are filtering the blood. See, but they are not filtering the cellular part of the blood, and some type of proteins are not filtered. Only glucose, amino acid, then creatinine, urea, uric acid, excess water, all are filtered. That filtrate comes into the tubular part. Then the filtered blood is taken back. The filtered blood is taken back by efferent, E-F-F-E-R-E-N-T, efferent arteriole. Efferent arteriole. The coming blood vessel is efferent arteriole. After the filtration, the blood free from nitrogenous waste materials are taken back by efferent arteriole. Now that filtrate goes into the tubular part, and here you see the filtrate contains amino acids, glucose, excess water, creatinine, urea, uric acid, and ions of sodium, potassium, chlorine, etc., etc. So every day in the human body nearly 180 liters of the urine is forming, but out of that an adult excretes maximum 2 liters of the urine, because you see again the useful whatever be the substances are reabsorbed by the tubular part. So here this PCT is there, no, proximal convoluted tubule. It reabsorbs glucose, amino acids, excess water, ions of sodium, potassium, etc. Because sodium ions and water quantity will be controlling the blood pressure. In that way, the functioning of the kidney is related to functioning of the heart also. So here in this proximal convoluted tubule, the reabsorption of glucose, amino acid, excess water, ions of potassium, sodium, chlorine are taken back, and that filtrate comes into the loop of Henle's. Then what happens here? This is the descending, this is the ascending. So ascending is moving up, descending is coming up down. The descendant tubule is permeable to water, ascending is impermeable to water. It is impermeable to what? Ions. Then what happens here? The whole water will be reabsorbed. The thick filtrate comes here, and here some ions are again reabsorbed. That filtrate goes into the DCT, that is distal convoluted tubule. And in this distal convoluted tubule, some of the ions are again secreted. That is called as the tubular secretion. Why again secretion means? This has to control, regulate the pH of the urine. So what happens here? Ammonia, some ions of the sodium, potassium, etc., etc. are here secreted. So this part is tubular secretion. So after that, the urine will be collected into the collecting duct and moves into the ureter of the kidney. So PCT is reabsorption, DCT is secretion, tubular secretion. That means the useful substances are reabsorbed in the tubules of the nephron. These tubules are permeability, they are having different permeability. That means one way it is permeable to water, it is impermeable to water, but more permeable to ions. Like that, the tubular part is having different permeabilities. So finally, the urine is collected into the collecting duct and moves into the ureter, from there to urinary bladder. So here the two parts we are discussing, the nephron part. One is the renal capsule and renal tubular part. Renal capsule consisting of number of coiled capillaries, small capillaries, which are surrounded by squamous epithelium. Then they are only the filtering units. The blood which is coming from the renal artery, that is through efferent AFFE arteriole, and then the filtration done in the Bowman's capsule, Then again the blood is going back by efferent arteriole, which is free from nitrogenous waste materials. Then the filtrate is moving through the tubular part. First part is PCT, proximal convoluted tubule, which reabsorbs the useful substances like water, amino acids, glucose, and ions of sodium, potassium, etc. And here the loop of Henle is having descending and ascending tubules, where it is permeable to water, it is impermeable to water, but permeable to more ions. Like that, some of the ions are again reabsorbed. Then here in the DCT, some ions like ammonia, etc. are secreted to control the pH of the urine. Finally, that filtrate forms the urine and goes into the collecting duct, from there to the ureter of the kidney. Thank you.